Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking it up from this topic of limits, and we are continuing our series of questions on JEE Advanced. So today's question we have taken it up from the year 2013, and if I talk about the question here which is given to us, it says that A belongs to R where R is the set of all real numbers. A cannot be equal to -1, and we have to find the value of a when the expression which is given to us that says limit of n tends to infinity. The numerator is given to us as 1 raised to a plus 2 raised to a till n raised to a divided by n plus 1 raised to a minus 1, and the other expression which is given to us here is n a plus 1 n a plus 2 n a plus 3 till n a plus n. So this is the entire expansion which is given to us. That's equal to given to us as 1 by 60. So we need to find for this expression equal to 1 by 60, what is the value of a. So we need to find that, and there are 4 options given to us. A is 5, B is 7, C is minus 15 by 2, D it's given to us as minus 17. We need to figure out the values of A. And again, this is a multiple correct answer question, so there can be more than one correct answer for this question. Let's figure out how to solve this type of question. So if I just find the sum of the terms in the numerator, that is 1 raised to a plus 2 raised to a till n raised to a. So if I have that sum here that I need to find out for. So if I need to find the sum for these terms, if I put a as 1, I understand that sum of the terms becomes basically the sum of all the natural numbers, 1 plus 2 plus 3 plus 4 till n. And we already know that sum is given by n into n plus 1 upon 2. If I put a as 2, I get this sum becoming 1 square plus 2 square plus 3 square till n square. And the expansion of that becomes n into n plus 1 into 2n plus 1 upon 6. If I put a as 3, I get this 1 cube plus 2 cube plus 3 cube till n cube. This tells me it becomes n square into n plus 1 the whole square. If I try to solve this further, I get this expression becoming n square by 2 plus n by 2. So I can write this expression as n square by 2 plus n upon lambda 1, where lambda 1 is some constant. Now if I try to solve this expansion, I get this expansion. If I solve it on the other page, I get this n into n plus 1 upon 6. So if I solve this, you get n square plus n, and you get 2n plus 1 upon 6. So if I solve this, becomes 2n cube plus 1 into n square, so n square plus 2n square plus n upon 6. So I understand if I split this, it comes to 2n cube plus 3n square plus n by 6. So I get this becoming n cube by 3 plus n square by 2 plus n by 6. So you get this expansion as n cube by 3 plus n square by some constant lambda 1, and you get n by some other constant lambda. So I understand this, that the pattern is being developed here. Here also, if you see n square and 2n plus 1 the whole square, you will again get the expansion as n raised to 4 by 4 plus n cube by some constant, n square by some constant, and n by some constant. So I understand this is the pattern being followed, that if I have a is equal to 1, I get 1 plus 1, that is n square, and whatever is the power is the base. Here if I have that a as 2, I get again a plus 1, which is 3, and the base same as the power. Here also if I have 3 plus 1, I get 4, and base as 4. So when I have the sum of these terms in the numerator, I understand my terms 1 raised to a plus 2 raised to a plus 3 raised to a till n raised to a will also become, for any value of a, it is going to become n raised to a plus 1 upon that same power as the base, so a plus 1 plus n raised to a will be with some other constant, n raised to a minus 1 will be again with some other constant lambda, and this will go on and on till the last term being n upon some constant lambda. Now, this is the expansion of the first part, that is the numerator. Now, if I talk about the denominator, I'll keep it this part as it is, but let's try to solve this term. So if I find the sum of that, I know the second part of the denominator is n plus a plus 1 and a plus 2. This goes on till n a plus n. So I understand here again that the first term, that is the first term a1, I should write in a plus 1, and this sequence is in geometric progression because difference between each consecutive term is 1, because you're adding 1 in the previous term to get the next term, so common difference is 1. So I know sum of the terms is basically given in arithmetic progression as number of terms divided by 2 into first plus last. So number of terms I have in this case is n by 2. First term I have n a plus 1. Last term also I have n a plus 1. And because there are n terms, I am writing number of terms as directly n. So sum of all these terms is becoming n by 2. This becomes 2 into n into a, because n a plus n a plus n plus 1. If you solve this further, again you get this becoming 2 and 2 gets cancelled. If you multiply n by 2 with the first term, 2 gets cancelled, you get n square a. So a n square plus n into n, it becomes n square again by 2 plus n by. So if I try to find the sum here, I have already got this. Now we have been told here that limit n tends to infinity, numerator, the sum of these terms in the numerator, it's given to us as n raised to a plus 1 upon plus n raised to a by lambda 1, n raised to a minus 1 by lambda. This goes on and on till last term being n upon lambda raised to n. Well, lambda is some constant. And here we have in the denominator n plus 1 raised to a minus 1. And the sum which is given to us, sum becomes basically n square. N square, if I take out common here, I get this becoming a plus half plus 1 upon 2. So you get n square common, you get a plus half plus 1. So this is the entire thing. Now if I take out common from both of those numerators and denominators, limit n tends to infinity. If I take out common from the denominator, let's say the highest power, it is n raised to a plus 1. So let's take out n raised to a plus 1 common. What I'll be left with is 1 upon a plus 1 plus, here since it is n raised to a plus 1, we have taken out common. We have to divide by 1 more n. So it becomes 1 upon n lambda 1 plus, here it will become 1 upon n square lambda till here we get 1 upon n raised to a minus 1, because we have taken a plus 1 common and n comes common, so it should be n raised to a, not a n raised to a. So it should be n raised to a to some constant lambda. Now, same thing if I do it here also, I can take n square common already. And from here, if I try to take, so when I take n square common, I have a plus half plus 1 upon 2 into n. And from here, if I try to take n raised to a minus 1 common, so here in the bracket, we will have 1 plus 1 by n raised to a. So now if you see this n raised to a minus 1 and n square, basically it gets multiplied and gets added up to form 2 plus a minus 1, which is a plus 1. So it again becomes n raised to a plus 1. And when that becomes n raised to a plus 1, I can directly cancel out these two terms. And now if I try to apply the limit, because these two terms have already got cancelled out, if I try to apply the limit, that is n tends to infinity, my terms become 1 upon a plus 1 plus 1 upon n now is going to be present in all the remaining terms in the denominator. So it becomes 1 upon infinity, 1 upon infinity, this goes on, and in the denominator you have a plus half plus 1 upon infinity again, because n is present in the denominator. Here you get this becoming 1 plus 1 by infinity raised to a minus 1. Now this becomes 1 upon a plus 1. All of these terms which are with 1 upon infinity, 1 upon infinity is becoming 0. So we get all of these terms turning out 0. This also turns out 0. This also. So now if I try to solve this, the denominator becomes a plus 1. And here you get 1 plus 0, which is 1. 1 raised to a minus 1 is 1. So your terms become 1 upon a plus 1. And here it becomes 2a plus 1. So now if I try to solve this expression, a plus 1, so 2 upon a plus 1 into 2a plus 1, and then is the value of the limit which we had been asked to find out. So we just figured out the value of the limit of this expression. We were also told that that is equal to 1 by 60. So if I equate this idea entirely, the answer which I get with 1 by 60, this basically turns out 120 here, and this if I multiply and take it on the other side, it gives me 2a square plus a plus 2a plus 1 0. If I solve this expression, I get 2a square plus 3a minus 190 is equal. So I have this entire quadratic equation with me here. Now just try to solve this and let's find out. A we know it's given by minus b plus minus root of b square minus c upon a. So if I know this idea, I know already a is 2, b is 3, c is minus 119. So if I know these ideas, I know minus 3 plus minus root of 9 minus 4 into 2 into minus 119 upon 2. So you get this becoming minus 3 plus minus root of 9 plus 8 into 119. So 8 9 is 17. 8 ones are 8, 15. 8 ones are 8. You get this becoming 9 and 4. That makes it minus 3 plus minus root of 961 upon 4. That makes it minus 3 plus minus 31 upon 4. So you get this becoming minus 3 plus 31 upon 4, or you get this as minus 3 minus. So this becomes 28 by 4, that is 7, or minus 34 by 4, that is minus. So we get two answers here that satisfies the question as the value of a, that is 7 and minus 7. So I get two correct answers for this question, that is B and D. So A and C are ruled out and we get two correct answers for this question, that is B and D. That can become the values of. I hope you have understood how to solve this type of questions of limits where n tends to infinity. So we just figured out the two sums of the numerator and denominator. Once we got the sum of the numerator and the sum of the denominator, we took out n raised to a plus 1 common from the two, and then we just substituted the value of n as infinity. That this is the answer for the limit. And since this limit was equal to 1 by 60, we equated and found out the value of a by using quadratic formula that gave us a's value as 7. That makes our answers of the question as options B and D. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE Advanced. So stay tuned. Also, do like, share, and subscribe to my channel, and do share these videos with your friends also who are involved in this preparation of JEE Advanced, so they can also take the benefit from these questions which we are solving. Thank you.